Good day, metric students. Today, I want us to spend a great deal of time just to try and apply a different part of our minds in solving this paper from GAUTEng. And for your cricketing knowledge, it's a June exam paper, Mathematics Paper 1. In my own view, this paper was very painful and students were set on a monumental failure. At least let's disagree in an agreeable manner that even the one from Limpopo, you had to solve those two papers with a long spoon, at least for the benefit of meeting of minds. This paper was consisting of algebra, number pattern, functions, and calculus. And for that reason, I'm going to do from functions up until calculus. And that is from question 4, question 5, the whole of it, question 6. Yeah, I'm going to reserve question 7 and 8. It's cubic graphs there, as well as algebra and number pattern. I'm going to couple it in one video. But for now, I don't want to waste so much time by giving some flimsy explanations. Let's start with question 4. That is functions, basically from grade 11. It's going to give birth along the way to grade 12. So just pay attention. I'm going to say question 4. Just gonna really write that. Just put it up there. So I want us to start with question 4. It's not really difficult. It's a straightforward task, but it can really hang you on the ceiling like a light bulb. Let's check. What are we given? We are given 4.1, and that is f of x is given by x squared minus 2x minus 3. That is a quadratic graph, or you can say it's a parabolic graph. You're also given a straight line that is a g of x, which is equals to x minus 5. That at least you are given. So that's a straight line with a gradient of 1, and of course with a y-cut of minus 5, which is 0 and negative 5 at the y-intercept of that line, for in case they want it. Now, let's check the first question. They say to you, show, I can zoom this for you guys. The first question, they say show that the turning point of f is 1 and minus 4 for the y value of that. How do you do that? This looks very simple. So I'm going to say 4.1.1. They want us to prove that the turning point of f is 1 and minus 4. In fact, there are 3 ways to do this question, but I'm going to give you 2 ways for now because the other one will require the x-intercept, which I don't have. Okay, so allow me to use the popular one, which is to say that x is equals to minus b over 2a. We call this the axis of symmetry of that parabola, okay, which is f in this particular case. Well, what is our b? Our b is minus 2. What is our a? Our a is the coefficient of x squared. In this case, it's minus 1, just right here. I'm going to have minus this minus here, and then my b is minus 2. Remember, b is the coefficient of x, okay, in a quadratic expression, or polynomial rather. This is 2 into a is 1. Well, this, if you do it nicely, it's going to give you 2 over 2, which ties down to positive 1. Therefore, x is equals to 1, the one which they are talking about just right here. Okay, we managed to get that. Now we need to get the y value. How do you do that? Because this is the axis of symmetry, so it corresponds to a minimum value. In this case, it's going to be a minimum because a is positive, just right there. Allow me to find that value. I'm going to say that y is equals to f of x in function. Okay, y equals to f of x in function. But this x is basically at the axis of symmetry, which in this case is 1. Okay, so I'm going to put a 1 here to get the corresponding y value, which in this case is going to be 1. Then I square that, minus 2 into 1, minus 3. You can really use a calculator if you don't trust your capacity. That is going to be 1 minus 2 minus 3. This is minus 5 plus 1 is negative 4, I guess. So I think you managed to prove that the point it's 1 and it's 1 and minus 4. So now I'm going to say therefore the point is 1 and minus 4. You're going to get the 3 marks for that. Okay, it's 3 marks, I guess. Let me check. Yeah, that is 3 marks. So I said to you, there are myriad of ways to finding this turning point. The other way would be to say that, think about it. You are given a f of x that is equals to x squared and then minus 2x minus 3. This is largely, the first method is basically for grade 11, just the warm up from grade 11, okay? I know you know these things. Now, for grade 12, you can use that to say, well, at a turning point, if you want to imagine this graph, it has a concave down view. So it's really going to look something like that, okay? That's how it's going to look like, by the way. So you want to find that point, that is x comma y, all right? So this point basically, at this particular view here, the first derivative, okay, of the graph is 0 because that is the turning point. It's basically the minimum point of this graph. How do you then get that point? You say, well, to get the turning point of any graph is to derive it. It's to derive the graph, which is going to be f prime at x is going to be equal to 0. So if you derive this, it's going to be giving you guys a 2x minus 2 is equals to 0. Therefore, this will be 2x is equals to 2. And you solve this linear equation by dividing both sides by 2. You're going to arrive to at least positive 1. You do the same thing, and then you substitute x into the given polynomial, which is going to give you minus 4. So this is the other way of doing it. Okay, it's also acceptable in grade 12. But we know the popular one, the straightforward one, is this one. Finding the x of symmetry. When you get that value, you plug it back to your f itself. Now, let me go to the next question. The next question here is possibly 4.1.2. Determine the coordinates of the x and the y intercept of f. Okay, so here they want what? They want the coordinate of the intercept of f and the x and the y intercept. What is f? F is given by, I'm just going to copy that again for free ears. That is f of x is equals to x squared minus 2x minus 3. Think about it, hey? The x-intercept, that's when possibly y is 0. Okay, so you need to solve for x here when y is 0, and this is y in function. So you're going to have x squared minus 2x minus 3. That is going to be equals to 0. Therefore, let's try and factorize this equation and see how far we can go with that. I don't know why students love to use quadratic formula here, guys. Please try to factorize sometimes just to save your time. You're going to have x and x. These factors here is 3 and 1. Doesn't matter where you place them. What matters is the sign here. The bigger number between 1 and 3 must take this middle sign. So 3 is bigger than 1. I'm going to have a negative there and a positive 1 there. Okay, therefore x is equals to positive 3 or x is equals to negative 1. Here, look guys, they want the coordinates. Okay, now the coordinates will then mean that it's when x is 3 but y is 0, just right here. Okay, y is 0, x is the one which you just solved it. You can just write, or it's going to have the x-intercept at negative 1 and y is still 0. Okay, so they want the y-intercept as well. I'm going to say that the y-intercept is basically the axis. Okay, that's where the graph is going to intersect with the axis. And I'm going to say, well, x here is 0. Let's do that quickly. I'm going to have y equals 2. In this polynomial, wherever there is x, I'm going to put 0 because x is 0. I'm going to say 0 squared minus 2 into 0. Then I take away 3 there. Okay. Now, if you do it nicely, you're going to get a 0 squared, 0. Any number times 0 is a 0. So you have a 0 minus 3, which is a minus 3. Okay. Therefore, the y-intercept basically is when x is 0 and y is possibly negative 3. You get free marks there. Things 3. They're giving you guys 3 marks there. It's a GAUTEng paper. I'm going to do everything in this paper on functions, all right? So far, that's how you solve it. You get 6 marks. So far, you have 6 marks. Let's see how to get the remaining marks on this question. Well, I'm going to say that we are going to 4.1.3. Allow me to zoom it. This question. They say to determine the points. So here they want the points of intersection of the graphs of f and g. So basically, they want the points where these two graphs meet. Okay, so you have f of x that is equals to x squared minus 2x minus 3. You also have your g of x, which is basically like a straight line with a positive gradient. And it's increasing, okay, minus 5. Now, think about it. Hey, they want you guys to find the point of intersection. My advice to students every time I teach them to say, well, this is where the two graphs meet. So the point of intersection basically simply means that this is where the two graphs are going to collide, okay? So that means f and the g are going to be equal at those points. So what is f? F is basically that polynomial there. It's a polynomial, by the way. And then you have a x squared minus 2x minus 3 is equals to the g of x, which is basically an increasing line of x minus 5. I think at this point, you guys have done a lot of algebra. You're in grade 12. You can solve this with your eyes closed. Some of you, let's check. You transpose x this side, okay? You have x squared minus 3, x, and then if you say minus 3, you add 5, it's possibly 2, is equals to 0. You need to factorize this. If you can't, that's when you're going to use quadratic formula, right? So you have x, 2, and 1. Look at this. It's positive. That means the signs are what? It's either positive or negative. But because this is negative, so that means both signs must be negative in order to arrive to negative 3x, okay? Well, really easy. You say, well, x is equals to positive 2. These graphs are going to meet at when x is 2 and when x is equals to 1. Hey, you need the corresponding y value of it. I advise students to take any graph to substitute the value of x into that polynomial. But you see, if I say any graph, students, they will even substitute in quadratic, which is not wrong. But the algebra is very weak. It's very poor. So I advise that you use a graph that is very simple. If you have a quadratic and a linear, obviously linear is more easy than quadratic. Okay, so I'm going to use the g of x because I don't have any square. I don't have tedious thing in it. Okay, allow me to use g. You could have used f, okay, to get your y. Therefore, y will be equals to, whatever there is x in this equation, I'm going to put 2. This will be 2 minus 5. That is going to give me negative 3. Think about it. You have two values of x, so you need to get the other one. Y will be 1 minus 5. As a result, you're going to get a negative 4. You are not done. They want the points. So most students are suffering from really concluding to the question or responding to the question. In this case, guys, they want They want the points. Okay, here they want the points. Let's do that. I'm going to say that therefore the points when x is 2, think about it, when x is 2, it's going to correspond to a value of -3. Allow me to put a -3 just right in there. Okay, and you have 2 points here. When x is 1, hey, when x is 1, it's going to correspond to a value of -4. Okay, so these are the points. I don't know how many marks they are giving you guys. 4 marks. Okay, so that's how you guys will solve it. That's how you guys will solve it. And these are the points of intersection. So basically, this point is very popular. I'm not sure if you guys recall that. This point seems to be very familiar. We've seen it. Like in the first question, I guess we had to prove it. So basically, these two graphs, they meet at the turning point, and at least when x is 2, of course, y will decrease by -3 down there from the turning point. Okay, so yeah, that's how you really go about that one. Allow me to go to the next question. I'm going to show you where the marks are when I'm done with these questions. Let's check 4.1.4. They want you guys to sketch. What are they saying? Sketch neat graphs of f and g on the same system of axes. Clearly label the turning point and where the graphs of f and g intersect each other, as well as the x and the y intercept of both graphs. Okay, so we have everything here. We have the turning points, the point of intersection. What I don't have, by the way, is the intercepts of, what do you call it, of g. But let me recopy this function f, that is x squared minus 2x minus 3, and I have a g, so g is x minus 5. I have the turning point, the x-intercept of f, but for g, I don't have it. Okay, so allow me to quickly solve them. I'm gonna say x-intercept of g. This is when y is 0. Therefore, you're going to have x minus 5 is equal to 0. You get x is equal to 5. Therefore, you have 5 and 0. You're not done. You need to get the y intercept of g. That's when x is 0. So you're going to have y equals to 0 minus 5. As a result, you're going to get -5. Therefore, the y intercept of g is going to be 0 and -5. Okay, it's really simple. So the rest, you have it. Okay, so let's try and pen it down graphically. I'm gonna try and really sketch them. Let me have the y-axis. In fact, the best way to draw a graph is to have a shape of the quadratic. So this graph is really, it's concave. It's concave down. So let's have it. No, it's concave up. What am I saying? It's concave up, eh? So there is the graph. It's concave up. Just trying to be very organic. Yeah, it's concave up, eh? There's a minimum value. So allow me to really have the y-axis there at -1. In fact, allow me to have the axis. I'm gonna play around that. Yeah, that's my axis. And then just want to be very careful and have the what do you call this, axis of symmetry, just right here. The point there is the point. Let's put that point. So the point in here is 1 and negative 4. We have to show it. We have to show it. Okay. So I'm going to say this is my y-axis and this is my x-axis. Okay. Now let's show them that this point we solve it to be negative 1, and then this one had to be positive 3. That means just right after 1, we'll have a 2 there. So 2 is gonna go down. Let's just really go down and have a value that is here. So that value is possibly negative 3. Okay, that's where it's gonna collide. You just need to draw it nicely. Hey, it's very much important that you draw something very, very healthy. In fact, I don't have to really stress myself that much. They want the shape actually. So allow me to really delete this part, because I'm just trying to be more accurate as best as possible. Yeah, something like this. Okay, so that means at that point, okay, give me a second. So that is 1 and minus 4, and they also meet here. At that point, that is 2 and negative 3. You can tell them that just down to the x-axis, that is 2. You can just tell them that. Okay, so what else you need to show? You need to show them that at this point here, that is minus 5. Okay, you can even write it as a point, like it's 0 and negative 5, and then here that is 5 and 0 for the x-intercept of that line. So that was G. Okay, that was G. And then for F, you can also write f of x, or just write f, only f. In fact, we normally write f, you know, just like that, f, and then here you just erase that f of x, you put G there. Yeah, that's how you really go about it. The sketching part of this graph, that's how it's going to look like, by the way. Now what I want to do, hey, is to check the next question. And if you have any question, please feel free to comment on the comment section below. I'll read it and take questions. I'm gonna write my email where you should post questions and solve them on YouTube. Okay. Now we have 4.1.5. They say to you guys, use the graph to determine the values of x where f is bigger than 0 or is above the x-axis. So where is this graph positive or above the x-axis? You need at least the knowledge of algebra and inequalities. This graph is above the axis in that region. I can shade it. Let me just shade it for you, and for 3 years. So this is where the graph is above the x-axis in this region. This graph is above the x-axis. We're trying to interpret it. This graph is above the x-axis. Bigger than 0 means above the x-axis or positive. Where is this graph positive? So this graph is positive above the x-axis. It's positive there. And where else? Let's check. It's also positive just right from 3 going to infinities. Okay, that's where the graph is also positive. Allow me to put a plus here to show that this is where the graph is really positive, and then below the x-axis the graph is negative. Okay, just so I answer even this question they didn't really ask it. Just gonna shade this part. This part, the graph is negative, okay? It's below the x-axis. Because I know they can do this for your trial exam and ask you, where is this graph less than 0? I'm just going to answer even that question. So this one is less than 0, is negative. It's below the x-axis. Think about it. They want the values of x where f of x is bigger or equals to 0. Be very careful. They are including 0 as well. That means you must include even your bounds here. In this case, it's quadratic, so it's defined everywhere. You have to be very careful. So this is positive when x is less than -1. Okay, so I'm going to say therefore x is less than or equals to -1, or in this region here, that's where the graph is positive. So from 3, that x-intercept from 3 to positive infinity, that's where this is going to be above 0. For those of you who may probably love to also check what they are doing in the IEB, this can also be written as x element of real numbers from negative infinity to -1 inclusive. Remember, or means union. Okay, this is or, and then from 3 again to positive infinity exclusive. So this is the same thing. Okay, you can just write in the interval notation in there, or in your set builder notation in there. Okay, this is basically inequality and interpretation. Now I'm gonna, because they are saying you need to end at 4.1.5, I'm just going to add extra question here, like 4.1.6. Use the graph to determine for which f of the value of x for which this will be less than 0. Let's put it down. 4.1.6. we're just constructing it. Okay, remember we are learning, so I'm going to construct this question: for which values of x will f of x be less than 0? So you're going to look at the graph like with a bird's eye view. You check where the graph is below the x-axis, which in this case I've marked in a yellow a highlighter there to say it is in between -1 and +3. Extremely easy, by the way. Look, by the way, I'm saying less than 1. I mean less than 0. So less than 0 is exclusive. That means you must not include your bounds. In this case, it's going to be in between -1 and 3. That's where the graph is below the x-axis, or is less than 0. That means negative. Okay, it's basically the interpretation. So I'll say therefore x is in between -1 and 3, or you can say x is bigger than -1 but less than 3. It's the same thing. And similarly, this is called set builder notation. You can write it in the interval notation, which is basically x element of real numbers inclusive of -1 to just 3 there. Okay, you get possibly 2 marks. Yeah, they're giving you guys 2 marks. So let's check where you guys get the marks here. I'm gonna start from the first question. It's 3 marks, so you need to get the value of x. Okay, x is 1, and you need to do the correct substitution and the value of y, the final answer. So they're going to mark you for the axis of symmetry if it's correct, and also the correct substitution and the final answer. And this ties down to 3 marks there. Okay, that's why you guys should accumulate marks. The next question is to determine the coordinates of that. So you're going to get 2 marks, possibly to get the factors of that one is 3 marks, and then you get your coordinates and the one for y-intercept. That is going to boil down to 3 marks as well. And then the other one is 4 marks. Being able to equate the 2 graphs is 1 mark, and you must know how to get the factors. It's very much important. I don't know why it's 4 marks, but you will possibly need to get the values of x and y there, and these values of y there. Okay, you get the 4 marks on that. It's really easy, very easy. And then the sketching, 6 marks. That's where you must show the point of intersection. It's 1 mark, 1 mark there. The intercept point for both graphs, and then the correct shape. This 1 mark for correct shape. Okay, that is 6 marks there. You get that. And then this one is 2 marks. It's that one or that one there, 2 marks. Or that in the interval notation is 2 marks. Also, that, if in case it was asked, but it wasn't, I just added that question. Okay, let's check the next question. Let's check the next question. That is 4.2. I'm going to be very fast here. I see I'm spending so much time here. 4.2, we are given f of x, that is 1/3 raised to the power of x there, or to the x power rather. So this graph is decreasing because, for in case they ask it, it's decreasing because the base there is between 0 and 1, exclusive of those. Now, everything is given here. So this graph is going to decrease. There is the graph, it's decreasing, and it's very clear that the graph is decreasing. Okay. Now, they say to write down the equation of the asymptote of f. What I want to warn you is that this is the parent graph of the exponential graph, the decreasing exponential graph, by the way. So in this case, the asymptote, we are talking about, it's either a vertical line or a horizontal line that the graph approaches but never touches. In this case, this graph is going to approach the x-axis, but it's never going to touch it. I'm not sure if you guys can observe that. We're approaching the x-axis, but we are not touching it. We are not touching the x-axis in there. So it means when when on the x-axis, y is 0, by the way. So here, y is equals to 0. This graph is going to approach the horizontal line of y equals to 0. And that is going to be the asymptote, by the way. So y is equals to 0. It's your equation of the asymptote. Or you can say to yourself, well, you are given this function f of x, which is equals to 1/3 to the power x plus q. So this q is not there. It is plus 0 there. This, whatever that comes after this basic graph, is called the asymptote, the horizontal asymptote of this mother graph, which in this case is y equal to 0. I hope I make sense, but we are sitting comfortably on the x-axis. Okay, and on the x-axis, that's when you have y equaling to 0. All right, so now we have 4.2.2. Let's say to you guys, write down the equation of the inverse of f in that particular form of y equals to something. Let's check that. We have f of x that is equals to 1 over, in fact, let's just read it because I have copied it, it's still there. So for f of x, that's when you have y equals to 1/3 raised by x there. And then the inverse of x, that's when you interchange the x and the y. Some books, they say that you use swap, or you use swap. Okay, not swipe, but swap. So you interchange a y to be x and an x to be y. That means you're going to have x is equals to 1/3 raised to the power of y. Well, if you solve for y, you can apply the laws of logarithms here to say y is equals to This would be the log of the base. The base is 1/3 of the augment. In this case, it's x. The augment is x here. Okay, that's the inverse of f. However, some schools, or maybe let me give you a glowing approach on this one, to say some books might leave the answer, or this can be written as let me just write on y is equals to negative of the log of base 3 of x. These two guys are the same thing. Let me tell you why. This is because, let me open a very small room here for myself. This is because, think about it. You have x is equals to 1/3 to the power y. And then you have x is equals to 1/3 is the same as 3 to the power -1 raised to the power y. Therefore, x is equals to 3 to the power -y. If you apply the logarithms here, the exponent in this case is minus y. Therefore, you have minus y equals to the log of base 3 of x. Think about it in this way, that if you want to solve for y, not negative y, you get y equals to negative of the log of base 3 of x. That's how this thing here is derived, but they don't want to see you deriving it because you can see it's 2 marks. I was just showing you where it's coming from actually. I was showing you where it's coming from. So y equaling to the log of base 1/3 of x is the same as negative log of base 3 of x. That's how we read it, by the way. So you get that. You get that. Now let's go to the next question. That is 4.2.3. Sketch the graph of f inverse. In your answer book, indicate the y-intercept. Indicate the intercept and one other point on the graph, to say. Okay, so we have the inverse, which is y equals to, it's entirely up to you to use 1/3. In fact, let's just use cool. Just have 1/3 of the log of base 1/3 of x. Then let's try and sketch it. It can really chow you depending on where you come from. Think about it. This I said to you just in a second, that y is equals to, this is the same as the negative of log of base 3 of x. Now, if you study very well functions, you'll see that this negative is the reflection on the in the x-axis, basically. So now, pay attention. Let me forget about that negative and try to think about this function here. Let's try and think about y equals to the log of base 3 of x. Now, you will say to yourself, this graph is not defined on the negative axis because the log does not take the negative values, okay? So, now, if you sketch this log, if you sketch the log of base 3, forget about the negative. If you sketch it, you would possibly have something like this. Think about it, okay? This is the mother graph of y equals to the log of base of that. And in this particular point here, you are going to have 1 as a parent graph of log of base 3. So this is the log of base 3. This is y equals to the log of base 3 of x. Now, that negative is a reflection of this blue graph. That means this point here, assume that that point there is 5 and something very big. It's going to, when you reflect it, it's going to be down there, and then the point that is here is going to be possibly somewhere here, and then the point that is here is possibly going to be, this is called the reflection of the points. Okay, this is how you reflect the points, like this, and then 1 and 0 is going to be at that point. And then now let's reflect this point. It's possibly negative half and something, so it's going to be up there with half, positive half, and something above the x-axis. Okay, that means if you go down and reflect it, it's going to be like that. So this is going to give you a very beautiful graph, by the way, behaving like this. That's the graph of the inverse, what they are looking for. So I'm at the same time teaching you graphs. So this tells us that to answer this question in the most autonomous manner possible, I will say that let me answer it now here. That one is just trying to show you something, like the reflection. Okay. Now, you can say with that view, you can say that this graph will behave something like this. Okay. There is the graph, beautiful people. There is the graph. It's going to be at 1. They want at least 1 point. So if when x is 1, that is going to be 0. Now let's check something. Let's check when x is, let's take any point. They want 1 point, by the way. So when x is, let's say maybe 3, you could have taken something, by the way. What is that point there? You go and substitute a 3 there. You go and substitute a 3 there. So let's check the log of base 1/3 of 3. I'm getting a -1. Okay, so I'm gonna have 3 and -1. Yeah, that is just 1 point that they're looking for. This is -1 when x is 3. So when x is 3, x goes to -1 there. That is the point which they are looking for. You don't have to really show this. I was just trying to give you at least a sense of justice there. Then we have that. We have that, and then I'll say that is the F inverse. They want the intercept, which is 0 and 1. You can even put it here, that this is 1 and 0, just to get full marks. So you get 3 marks there, the shape and the point. Let's just get that point there and the shape of that. So, but you had to really picture it from here. Okay, I'm gonna post the functions, a video on functions, like the inverse, even the quadratic inverses and stuff, but mostly this one of logarithm. Sometimes students really face a palpable jungle. Allow me now to go to the next question. So let's check, we're done with the first question, the second question, even the third one. Now we are going to 4.2.4. Write down the equation of the asymptote of that one. So they want us to write down the equation of the asymptote of this one here. So think about it. When they say f of something, maybe f of 2. This means in f, wherever there is x, I'm going to substitute with 2. So this means in the inverse function, wherever there is x, I'm going to substitute with x plus 2. What is the inverse, by the way? The inverse was given by, it's entirely up to you to use 1/3, the log of base 1/3 of x. This was the inverse. Now, they say find the equation of the asymptote of x plus 2. Now, look at this. In a position of x, we're now having x plus 2. So, this position here, wherever there is x, I'm going to put x plus 2. So, I have a log of base 1/3 of possibly, it's x plus 2. Okay, so that is x plus 2 there. So they want the equation of the asymptote. So what is the asymptote? The asymptote occurs when the augment is 0. So what's the augment? The augment is that principal arrangement there. When that part is 0, this is going to be undefined. Remember that the asymptote, it's either a vertical or a horizontal line, or even a straight line if you are dealing with high complex functions. If even your rational functions, you can have a straight line, not even vertical. In this case, grade 12, we deal with vertical and horizontal. In this case, we're going to be dealing with the vertical because this portion here consists of x. So I'm going to say, therefore, when x plus 2 is equal to 0, the log will be undefined. Think about it. Any log of 0 is undefined. That's why we're saying this principal angle, whatever that is inside the logarithm, really must be 0 in order for that to be the asymptote. Therefore, x is equals to -2 is called the equation of the asymptote. Okay, just so I emphasize this point, you see this graph here, it has the augment of x. Therefore, its equation of asymptotes is going to be x is equal to 0. Okay, this part here must be 0. And you can see that just right on the y-axis, when x is 0, on the y-axis, just right there, this graph will have x is equal to 0, and we are approaching it, and we are never going to touch it. Okay, that's how best you guys can solve this particular graph here. Allow me to go to the next question for the benefit of time. Okay, so I want to say that 4.2.5 prove that, so you have to prove that some funny arrangement there, which is f of x raised to the power 2 there, minus f of that part, and then negative x, I meant to say, that stuff there is equals to f of 2x minus f of negative 2x. So when you prove, guys, you have two sides. Okay, so remember that we are dealing with f, not the inverse. Okay, so f was given by 1/3 to the power x there. Now let's check very quickly. I will say the left hand side is equals to this portion. Let me copy that. So that is f of x raised to the power 2 minus f of negative x, and then you square that. So let's square f. What is our f? Our f is 1/3 to the power x. You have to square this minus, you do the same stuff. So that is wherever there is x, now you're putting negative x. So that is 1/3 to the power negative x, and then you square that, and then you simplify it. So you multiply the exponent this becomes, or you can even interchange the exponent in that way. So you will have 1/3 to the power 2x, okay? And then now you're going to have minus, multiply negative x and 2. This becomes 1/3 to the power negative 2x. That's the left hand side. You can simplify it if you want. If you have so much energy, you can say that is the same as 1/9 to the power x minus possibly this should be 9 to the power x. Okay, it's the same thing, but you can end like in that step, you know, it's the same thing. You'll try and investigate what is that. I'm looking at the time now. I don't want this video to be very long. And then the right hand side, let's go and check that. So the right hand side is f of 2x minus f of negative x. Okay, so that means whatever that is x, I'm going to put 2x. So this becomes 1/3 to the power x. So x is 2x now, minus 1/3. Whatever there is x, we're putting what? Negative 2x. So this is the same thing as that step there. So you can even say, therefore, now the same thing, eh? Therefore, the right hand side is equals to the left hand side, or vice versa. You get your full marks there on functions. It's 29 marks. Okay, it's extremely easy, but sometimes really tricky. So let's get to the other questions, which is basically hyperbolic. That is hyperbolic, and then we go to calculus. It's very easy. So let's see, question 5. Question 5, okay. Let's check question 5. You are given f of x that is equals to a over x minus p there, and then plus q. There's a particular point t there that the graph passes through, that is 5 and 3, okay. Well, you need to be very organic on this type of questions. Think about it. You're given the graph that you must interpret, even though they are drawing some funny stuff here. I saw this branch there. It's really in a palpable space. But let's pay attention to what we have to find. They say to you, determine the values of A, P, and Q. Check something here, guys. This belongs to the first quadrant formed by the asymptote, okay? And you also going to have something in the third quadrant. So this, in a sense of justice, is trying to tell you that let me just really do this. It's telling you that the values of the value of A there is positive. So A is positive because of the shape. The graph is divided in the first quadrant and the third quadrant formed by the asymptotes, okay? And you have how many marks? It's 4 marks. They're giving you something here. Everything is given here. Like Q is passing through. Q is passing through. I think it's 2. Let me just try and zoom it. Yeah, this should be 1, 2, 3, and this one should be 4. Is it 4? 2, 4, 6. Yes, that should be 4. I'm just trying to read the points there. So 5.1 determine the values of A, P, and Q. So I can start with Q. So my Q is 2. Okay, it's just this value here. The value The value that is here is the value of Q, this horizontal line here. Let me just draw it here. It's passing through 2, and then the vertical line is your the vertical line is P, and then the horizontal one is Q. So the order in which you place it doesn't really matter. And then P is at positive 4, right? So that means that that should be negative. So P is negative 4. Okay. So P is possibly negative 4 there. In order for that to be positive 4. So this means that you have y equals to a over x minus p, that is minus 4, and then a plus 2. In this particular case, we're going to use at least a 1 point to solve the value of a. So I'm going to say at t, that is 5 and 3. All right, let's solve the value of a there by plugging into this equation. This becomes 3 is equals to a over x is 5 minus 4 plus 2. That is 3 is equals to 5 minus 4, or 4 take away 5 is 1. That is a plus 2. Therefore, a is equals to positive 1. So that means a is positive, and it tells you that you are correct, because even the graph shows that this graph here is positive. So a is 1 there, and then that Q you get 3 marks so far, and the correct substitution for solving the value of a, that is 4 marks. Allow me to create more rooms. Okay, so yeah, that's how you really go about question 5. In my understanding, it's not really complex. That's how you guys should have solved that. And then 5.2, they say if the graph of f is reflected across the line, if the graph of f is reflected across the line having the equation y equals to minus x plus c, and the new graph coincides with the graph of that, which is f, determine the value of c. Okay, so what I want you guys to observe is that there's a new graph here. I mean, the graph of f is reflected. If the graph of f is reflected across the line having the equation y equals to minus x plus c, and the new graph, okay, coincides with the graph of y, which is equals to f. So they intersect with f, and let me just mark that. So that is f, and this is a new graph. But if you check that new graph, it's basically your equation of axis of symmetry, but with a negative gradient. Remember, you have 2 of them. So the first one to say that y equals to x plus p, I mean, this should be minus p, hey? Minus p plus q. You also have y equaling to minus x plus p plus q. So this one is called the equation of the axis of symmetry with, of course, a negative gradient. It's the one which we have here, and they all coincide with the graph of f at 1 point, rather. So I'm going to say, because I'm given this equation, I must find the value of c. So allow me to then say that y is equals to negative x plus p plus q. Negative x, what is p? What is your p? Your p, you found that to be negative 4, okay? So you will have a minus 4 plus q. What is q? Q was 2. So therefore, y is equals to negative x, and then minus 2. They want the value of c, remember that? So you will then say that the value of c is equals to negative 2. Okay, that's how you really solve that particular question. It's really easy. It's really easy, and that is 2 marks. Okay. It's a negative gradient axis of symmetry equation. You have 2 of them. Okay, they all coincide with the graph of f. So there are other ways to do it, by the way, and I'll post more videos on this type of questions. We'll see how far we can go with that. Now let's check question 6. That is calculus. We have spent so much time. I want to spend 30 minutes, but I think I've overused my duration here. Question 6. Question 6. It's basically your most favorite question. That is f of x is equals to 3x minus x squared. You are given that, and they say use the first principle, which is a definition of derivative, to calculate the f prime at x. I'm not going to waste so much time. I know you can do this with your eyes closed. You have f prime at x is equals to the limit as h tend to 0 of f of x plus h minus f of x. We have to divide this whole stuff here by h. Okay, divide this by h. Very quickly here, wherever there is x, I'm going to put x plus h. Okay, so let's do it very quickly. That is 3 into x plus h minus x plus h, and then you have to square that and take away the function itself. That is 3x minus x squared. Close that and say divide this by 2. I mean by h. I don't know why 2. Let's try to be very quick. And then you remove the brackets. Okay, so that is 3x, and then you have a plus 3h. You need to really remove this carefully, and you're going to have a negative x squared, negative xh, and then negative h squared. Okay, so because of space, allow me to reduce this. Allow me to reduce that, and you simplify that as well. That is negative 3x, then a plus x squared, and you divide this by h. Let's check. It should be very easy. Okay, here seemingly some terms are going to undo each other. What are those terms? 3x and minus 3x minus x squared and x squared. So what are we left with here? Here we are left with oh, I think I made a mistake here. This should be minus 2x. Okay, when you expand that very carefully, be very careful. So now we have a 3h minus 2xh minus h squared. We have to divide this by h. For the benefit of space, I'm just going to reduce these. Okay, so let's divide each term by h. Oh my goodness, I forgot the limit. I humbly apologize, guys. I don't know why I dropped the limit. I therefore ask you guys to forgive me. You don't drop the limit. You do not drop the limit. So that's the limit as h tend to 0. the limit as h tend to 0. You have the limit as h tend to 0. You still continue with it even here, the limit as h tend to 0. Think about it, huh? You simplify the numerator, this expression, you divide each term in the numerator by h because they share the common denominator of h. That is going to be 3 minus 2x minus h squared. Hey, I'm really sorry for forgetting this limit here as h tend to 0. You don't drop it, okay? This is the time where you drop it. You substitute h here in the expression. So that is going to give you 3 minus 2x. Okay, that is the derivative of that from the first principle. I humbly apologize for forgetting the limit here. It's not allowed. Okay, I hope I'm forgiven. Let's check 6.2. They want us to find dy by dx, and then 6.2.1. You have y equaling to x minus 3 the square root of x divided by x squared. So allow me to really write this equation here in the power form, like I simplified nicely before I take any derivative. So that is going to be y equaling to x minus 3x to the power 1 over 2. We remove that radicand to a power of half, divide by x squared. So the numerator, I'm going to simplify it similarly to the one that I did here when I was simplifying this one, that each term in the numerator, they share the common denominator of x squared. In this case, previously it was h. Okay, so let's do that. We get x over x squared minus 3x to the power 1 over 2 over x squared. You simplify this nicely. This leaves us with y equals to, in a power form, this will be, it's going to cancel out to be 1 over x. So 1 over x is the same as x to the power negative 1. Okay, if you simplify it nicely. And then this one is going to be minus 3. And then x is, you say half, take away 2. It's possibly negative 3 over 2. Okay, that's that. And then now you can derive it to say dy by dx is going to be negative of x to the power negative 2. Remember to take away 1 from the exponent. And then same thing here. You say negative 3 times negative 1.5. So that is a positive number, 9 over 2. And then x, if you take away 1 from that, it's basically going to be 2.5. So it's negative 5 over 2. You'll correct me if I made some blunder here. Sometimes I make some blunder, like you saw. I forgot the limit. This is because I'm getting tired. Okay, so let's leave our answer with a positive exponent. We're almost done, guys. This is negative 1 over x squared and plus 9 over 2x to the power 5 over 2. That is our dy by dx with a positive exponent. Okay, I think you get it. It's not really difficult. Let's check the second last problem of the day. That is 6.2.2. You have y over 3x is equals to 1 plus x to the power 2. It's a binomial. Let me clear fraction before I derive it. Multiply both sides by 3x. That is y equaling to 3x into 1 plus x is a binomial. And then it's squared. Okay, the perfect binomial, by the way. Y equals to 3x into, you try and really expand this. So it's going to give you what now? 1 plus 2x, I guess. Plus x squared. Be very careful there. Y is equals, you can now distribute this whole stuff. That is going to be 3x plus 6x squared. And then a plus 3 x to the power 3. You just multiply that trinomial, with 3x there. Now you are allowed to take the derivative. It's already in the power form. Dy by dx is 3 plus 12x plus 9x squared. Okay, so that is the answer of that problem. Yeah, that's how you guys should derive this. It's really not difficult. Okay, so yeah, that's how you guys should solve it. 6.3, the final problem of the day. We are given h of x, that is equals to ax squared plus b over x. Let's check this. Say a function h is given by h of x, which is equals to ax squared plus b over x. Okay, so this h is given like that and has a minimum value. Please get that. A minimum value occurs at the first derivative. Has a minimum value of 12 if x is 2. So what they are doing then is that at the first derivative, it's a minimum. Okay. And what I want you guys to see is that this a, if it's a minimum, it means this graph is like this. And a is what? A is less than 0. A is negative. So when you solve it, a should be negative, right? No. A should be positive. This is a minimum graph. So a here is positive. There's a minimum value there. So let's check. So they're saying when x is 2, this graph has a minimum value of 12. Okay, so that's what we have. The best thing to do here, this means derivative. Okay, this is calculate the value of a and b. Oh, let me use h because we are dealing with h, okay, not f. So let's derive h of x. We get a 2ax. If you derive this, it's going to be minus, think about it, it's minus b over x squared. All right, if you derive, be very careful on your derivatives there. So now again, this has a minimum value. So when x is 2, by the way, so let's try and really solve for value of a then. It should not really be that difficult. And what I also want to let you know is that the point here at the minimum is 2 and 12. Okay, but this is a derivative. It should be 0. Okay, so that is going to be 0 there. When x is 2, that is going to be 2a into 2 minus b over 2. Then you square that. Let's check the maths. Multiply throughout. That is 0. It's 4a minus b over 4. Let's multiply throughout by 4. So we get 8a. Oh no, it should be 16a. We get 16a minus b is equals to 0. So that is the first equation. It's linear. We need to get the other one. So the other one, this is the minimum point, but 12 is a value. It's a minimum value of the quadratic. So what I'm going to do now, because that point passes through f, I'm going to substitute it. Okay, to say that let's do that. H of 2 is equals to 12 as well. Okay, so let's check. H of 2 is 12. This is going to be 12 is equaling to x. So it's possibly going to be a into 2. You square that, and then a plus b over 2. Okay, Simplify this nicely. It's going to be 12 is equals to 4a plus b over 2. With clear fractions there, it's going to be 24 equaling to 8a plus b. That is called equation number 2. So, how do you then solve this? Should be very easy. Let's add the two equations. Let's add the two equations, equation 1 and 2. I'm going to use elimination. So, 24 plus 0, that is 0, is equals to 16a. What am I saying? 24 plus 0 is 24. And then 16a plus 8a. So 16 should be 16 plus 8, possibly 24. So this is 24a, and then minus b plus b, that is possibly a young 0. So therefore a is equals to 1. A is equals to 1. And then you can substitute this a to get a b in any of the equation. I'm going to substitute in equation 2 because I can see it just right here. Substitute a is equals to 1 into equation 2. So therefore, b is going to be 24 minus 8 times a is 1. Be very careful. That is 24 minus 8, there should be 16. So the value of b is 16 in this particular problem. Okay. So that is 16. That is 16, the value of b. And the value of a is 1. That's how you guys should have solved this particular question. So I'm a bit tired. I'm going to do question 7 and question 8. It's optimization, question 8. And then question 7 is basically like your cubic graph. I'm going to start from algebra, how to solve for x here, and number pattern, your sum, how to prove the arithmetic series as well, and to do some calculations around the quadratic sequence in them. As of now, let me say, guys, thank you so much for sticking and staying with me for this paper. I'm also going to do paper 2 as well. I'm gonna post it, so just keep checking on my YouTube channel, and don't forget, guys, to